In this video, I shall show you the TR55 method design module. I click on TR55 method. This opens the TR55 method design folder. The method is based on USDA Natural Resource Conservation Service NRCS Urban Hydrology for Small Watersheds Technical Release 55 or TR55 Manual. At the top, you will see a pull-down list of all counties and the principal cities in the Commonwealth of Virginia. Table 11B.1 of Virginia Stormwater Management Handbook, Chapter 11 provides the 24-hour rainfall depths for Virginia counties and major cities. For counties having more than one rainfall zone, the appropriate approximate boundaries of the various zones are suffixed. These values use the Atlas 14 precipitation frequency data. It is therefore important to make the county selection if a designer wishes to use the NRCS data. I can select the units, English, for the United States customary units, or metric for standard international units. The peak flow for a storm event is a function of drainage basin area, potential watershed storage, and the time of concentration. Below the county or city field is the number of sub-areas field, where I can select the number of sub-areas for each type of land use within the drainage area. Table 2.280 of the TR55 manual give runoff curve numbers for different land use cover types and hydrologic conditions, HSG. I can select up to 10 sub-areas for different land use and HSG. Let me select 5. This opens a table of sub-area description, corresponding area, A in acres or hectares, HSG, and the corresponding curve number, and the product of area and curve number. The number of rows in this table correspond to the number of sub-areas selected. To the left of each row is a Help button. Clicking on this button opens a new form giving runoff curve numbers for different land use cover types and hydrologic conditions. You will note that there are 5 subfolders corresponding to tables 2.28 to 2.2d of the TR55 manual. I select the applicable CN value for the specific land use and the HSG in this folder. When I click on the CN value, I am returned to the main form with the selected land use type, HSG, and the corresponding CN value populated in the selected row. I fill in the sub-area field. I repeat the steps for all the 5 sub-areas, and click the Accept button. This calculates the product CN and A for each sub-area, total A, both in acres and in square miles for English units, and in hectares and square kilometers for metric units, total of CN and A, and the weighted CN value for the total drainage area. I can always click on the Clear button to restart the above steps. When I click on the Accept button, you will notice that the 24-hour rainfall depths for the 2-year, 10-year, 25-year, 50-year, and 100-year rainfall events are automatically populated based on applicable Atlas 14 data for the selected county or city. I can override these values by keying in specific rainfall depths. Time of concentration, TC, is the time for runoff to travel from the hydraulically most distant point of the watershed to the point of interest within the watershed. The time of concentration consists of sheet flow, shallow concentrated flow, and flow in man-made structures such as channels and pipes. You will note these flow types are shown at the top right with the Help button to the left of each. When I click on the Help for sheet flow, a new worksheet opens to show the procedures for calculating sheet flow. Sheet flow is limited to 100 feet, or 30 meters. I enter the flow distance, the upper and lower elevations of sheet flow, and surface description. Once these fields are entered, and the Accept button is clicked, I am returned to the main folder with the selected TC populated in the TC field for sheet flow. TC is measured in hours. When I click on the Help for shallow concentrated flow, a new worksheet opens to show the procedures for calculating shallow concentrated flow. The average velocity for this flow is a function of watercourse slope and type of channel. I enter the flow distance, the upper and lower elevations of shallow concentrated flow, and the surface type. Once these fields are entered, and the Accept button is clicked, I am returned to the main folder with the selected TC populated in the TC field for shallow concentrated flow. There are 2 rows available to enter shallow concentrated flow for differing slope and type of channel. I repeat the above procedure for the second row. I follow similar procedure for channel and pipe flow conditions. One can key in the velocities instead of depth of flow or diameter of pipe respectively. After entering different flow types, I click on the Accept button. The TC is accumulated, and the total time of concentration is populated, subject to a minimum of 0.1 hour. The peak discharge using the graphical method requires knowing the rainfall distribution, 1A, 2, or III, for the locality. The appropriate rainfall distribution for the Commonwealth of Virginia is Type 2 distribution. The additional input is the pond and swamp areas. If these areas are spread throughout the watershed and are not considered in the TC computation, an adjustment for pond and swamp areas subject to a maximum of 5% is needed. I next click on the Compute Discharge button. The program calculates the runoff depths for the 2-year, 10-year, 25-year, 50, and 100-year storm events in inches or millimeters, and the corresponding peak discharges in cubic feet per second or cubic meters per second, as appropriate at the bottom left of the form. I can preview and print the results either as PDF file or send to printer. Exit will close the TR55 method folder. This completes the TR55 method module.